Hey guys, today let's solve the binary tree inorder traversal problem. So, this is the given problem, right? They are giving us the root of binary tree and we need to return in inorder traversal order. So, first we need to understand what is traversal in binary tree or tree. Well, basically, traversal means we are visiting all nodes, right? In a specific order. There are three types of traversal in tree or binary tree. The first one is pre-order traversal. Well, what is that? Pre-order traversal means we are visiting the nodes from the root, then we are visiting the left side and right side. How about in-order traversal? In-order traversal means we are visiting them from left, root, and right. Then post-order traversal, we are visiting them from left, right, and root. Let's take a look at the example 1. Let's say the given root is 1, 0, 2, 3, right? Like this. If we are visiting them from in-order traversal, it will be 0, 1, 3, and 2. Let's take a look at the example 2. This is the given tree or binary tree. If we are visiting all nodes in in-order traversal, it will be 4, 2, 6, 5, 1, 7, 3, 9, and 8. Is that correct? Yes. Then what if the given root is empty list? We will just simply return the empty list. Then what if the root is only 1 node? Well, we will just simply return the 1 node. Let's take a look at the example 5. Let's say the given root is like this. We're gonna visit in order traversal, right? Which means we visit from 4, then 2, 5, 1, and 3. Okay. So the goal is to return all visited nodes in order traversal. To solve this, we can use DFS iteration style or DFS recursion style. Well, before that, we need to understand the main thing of this problem. The main thing is that in-order traversal means we are visiting from left, root, and right. For the iteration style, first, if the given root is null, we just simply return. Then DFS is using stack, right? So we need to create new stack to store the visited node. After that, we are pushing the stack, push the root into the stack. Then, while the stack is not empty, it will be, hold on. The last one is return the result, right? But before that, we have this. Visit left sub-tree, then we need to structure the result by removing the visited node from stack. Then we visit all right sub-tree. Okay. So let's say the given root is this. Sorry, one stack is not empty and current node is not null. So let's say the given root is like this and the root is 1, 2, 3, 4, 5, null. So at first the stack will be empty and the current node will start from the root, right? So while stack is not empty and current node is not null, which is true, then we're gonna push the root, which is 1, right? Then we move to the left node because we are visiting a left sub-tree. Then So it will be current node is node1 dot div, which is node2, right? It will continue again, stack dot push 2. This one will be stack is 1. Then this stack will be 1 and 2. Then the current node will be node2 dot div, because we want to visit our left subtree, right? Which is now is node 4. Then stack dot push 4, which is stack now is 1, 2, and 4. Now the current node is node 4 dot div, which is node 4 doesn't have any child, right? So it will be then because there is not any left node, right? We're gonna structure the result and remove it from stack. Stack are last in first out, so it will be pop. We're gonna use pop. So now the stack is only have 4 and 2. The current node is 4, right? Because we get it from the stack. So result will push 4. Now the result is 4. After that, we are visit the right subtree. Is 4 have any right subtree? No, it's not, right? So we will just continue. Current node is stack.pop. The stack now is only 1. Then the current node will be 2, right? The result will push 2. Now the result is 4 and 2. Okay. Then is 2 have any right node? Yes, which is 5, right? So it will be visiting the right node, which is node 2 dot right, which is node 5. Then we push it to the stack, right? Stack dot push 5. Now the stack is 1 and 5. Then is 5 has any left node? No, right? So we continue to structure the result. So it will be current node stack.pop. Stack now is 1, only 1. Now the result will push the 5. The result will be 4, 2, 5. Because 5 doesn't have any child node, right? Either left or right, we will just continue. Hold on, this. We'll remove the 1, then result.push 1. We'll have 4, 2, 5, and 1. Now, is 1 have any right node? Yes, which is 3, right? So current node will be node 1 dot right, which is node 3. So stack dot push 3. Now the stack is 3. Then we structure the output again. Stack dot pop will be empty, then result dot push 3, and we just exit the looping. Return the result, which is 4, 2, 5, 1, and 3. Okay, until that's all for the diagram. Let's turn them into code. Cons in order traversal, they are giving us the root. Okay, then if the root is null, return, right? Then the fs are using stack, so we need to create a new stack. And we need to track the current visited node, right? So we need the current node, which is starting from the root. Then while the current node is not null, current node is not null, and no, we shall use all. Stack dot length is bigger than 0. Then we visit the left subtree and structure the result. Visit the right subtree. So it will be, well, current node is not null, right? We're gonna visit the left subtree. So it will be stated push current node. Then we move the pointer to the right side, right? Sorry, the left side. Then we move the pointer to the left side, right? The current node will be current node dot left. Move the pointer to the left side. Then we structure the result. Current node is stated pop. This one is because step is before last in first out. So we're gonna push the current node to the result. Move the pointer to the right one. Okay, I think that's all. Then we just simply return the result. Okay, let's do the time space complexity analysis. This one will be O and space because we need to store our visited node, right? And this because we visit our node at least once, it will be O and time because we visit our nodes at least once. Okay, that's all for the iteration. Let's continue to the recursion one. Recursion, it will be the same, where the main thing is in-order traversal. We visit from left, root, then right. Okay, then it will be the same if the given root is now return, right? Then we need to create the traverse function to visit the nodes in order traversal. Okay, return the result. But before that, we also need to create result to store the visited node. So inside of the traverse function, if the node is null, we return. Then visit the left subtree. Then we push to the result to validate and process the root. After that, we visit the right subtree. I think like that's all. Let's see the try run. Let's say the given input is 1, 2, 3, 4, 5. Now, well, let's do the try run, right? So this is the given root. I'm gonna put it on here. First, we're gonna call the root, right? Traverse 1. Then this will call the left node, which is 2, right? So it will be traverse 2 and call traverse 3, right? And inside of the 2, it will be call traverse 4 and call traverse 5. Meanwhile, for this, because they doesn't have any child node, it will be traverse null and traverse null. It will be just simply return and return. For this, for will also be same. For doesn't have any child node, right? It will be call the traverse null and call the traverse null. So first, we're gonna push the 4 to the result, so the result will have 4. Then we backtrack to node 2. Now the 2 is push to the result, right? Now the result is like this. Then we backtrack to not 5. Okay, then the not 5, so the not 5 doesn't have any child node, right? So it will be result that push 5. Now the result is 4 to 5. Then we this one should be backtrack to not 4. Then this one will be backtrack to not 2, and this one is backtrack to not 5. Then this outside of this will be result the push 1. Now the result is 4, 2, 5, and 1. For this, we're gonna push the 3, right? Now the result is 4, 2, 5, 1, and 3. Because on here, backtrack to not 3. I think that's all for the dry run. Then let's turn them into the code. Cons in order traversal. Then this one is root. If the root is null, we just simply return. Then we need to create the traverse function, right? Traverse, it will be not. If the not is null, we just simply return. Okay, then visit the left node, which is traverse, not the leaf. Then we push not, and this one is to visit the root and get to result or validate. Then this one is visit the right node. It will be traverse, not the right. Okay, then on here we're gonna call the traverse root and return the result. Okay, I think that is all. Let's do the time and space complexity analysis. For this, because we are visiting all node, right, it will be all and time. And because recursion are using state, right, it will be all and space. Okay, I think like that's all. All and time and all and space for the recursion style. And this iteration style is also same. All and time and all and space. Let's try them. Let's say the option 1 is DFS iteration. So first, if the root is null, we just simply return. Then let current node is the root to track the node. Then let's take this empty list. It will be to store the visited node. Then while the current node is not null, right? Or stack the length is bigger than 0 while current node is not null, right? First, we need to visit all left subtree. So this one will be visit left subtree. Then this is structure the output and remove from stack. And the last one is we visit the right subtree. It will be current node dot right. We move the pointer to the right. And for this, we're gonna push them right. stack the push current. This one should be this. Then we move the pointer to the left. It will be current node dot left. Move the pointer to the left. Then structure it from the stack. No, we move it from the stack, right? Stack the top. This one is because stack are level. Then result dot push current node dot fall, and we just simply return the result. Let's see if it's working. Oh, sorry, I forgot the result. That result is like this. I will just move it to here. Then if the root is empty, we will just return the result. Okay, it's working. See? Then how about the option 2? Okay, let's just delete it. Option 2, that is if as recursion style, that result is empty list. Then if the root is null, return result, right? Then we need to create the traverse function. This will be null. If the node is null, we just simply return. Then visit the left subtree, which is traverse not dot div. Then we visit the right subtree, which is traverse not dot right. And here we gonna process the root and validate. Result the push not. Okay, then we're gonna start from the root and return the result. Let's try. Oh, it should be traverse. Return type this is integer. It should be not that far. Okay, let's just submit. Yay, it's working. I think like that's all from me. See you next time.